Hello everyone, and welcome to our continuation of assignment of variables and literal values in Java. We're going to finish up talking about chars now. We'll move on to strings, and then we will continue with a new topic focusing on arithmetic or basic math in Java. So last time we mentioned the char variable type that holds single characters. We mentioned their Unicode, and we saw there's a huge list of characters from many different languages that can be assigned. We started showing that literal character values are in single quotes, and I showed these three examples of a lowercase letter, a space, which is the one that's a little bit odd, mainly because it is a visual space that occurs between the single quotes, and then a capital letter, and that capital letters are distinct from lowercase letters. I mentioned that I wanted to talk about some special single characters in our language, and this happens because of two reasons. One, because there may not be a symbol representation of a key on a keyboard or a particular character, and even if you have maybe a non-American keyboard, it still might have that same problem. And also because certain characters have meaning in the language itself, in Java. And so for us to try to use that character could confuse the language. It thinks that we might want to use it in terms of the language, Java, not necessarily literally, and that's a problem. So we have to kind of solve those two problems. So the solution is the idea of what's called an escape character. And this is essentially a character or a symbol that tells the compiler, the computer, that the next character beside it is not to be interpreted in the typical fashion, but in some alternative way. And so for literal characters, most of the time, the typical fashion, the standard, is literally. So this is a literal A. When we use the escape character, we're going to say, well, interpret this letter instead as an A as something else. Now, not every single normal character has an escape equivalent, but several of them do. And so we'll talk about those. And so before I go ahead and start, I'll go ahead and put a note, and we'll say escape character. Right. Symbol that tells the computer to interpret next value in a, and I'll put in quotes, non-standard way. And again, this is it says, well, instead of looking at it normally, look at it in some other fashion. It means something different. And so what is the escape character? In our language, in Java, it is the backslash character. Backslash, right? As opposed to the forward slash, where we use two forward slashes for comments, and we'll see that we use it single forward slashes for something else briefly. But backslash, a single backslash, is meant to escape another character. So you pretty much never use a single backslash on its own, because it has a very specific meaning. So let's do an example. I'm going to go ahead and say, we're going to use symbol, which is the variable that we created last time, and we'll go ahead and say symbol equals. And now if I put the letter N, the default behavior is a literal N. If I escape the N, then we're going to say interpret this N in a different fashion, not in the normal way. And that's important because what does it mean to be a non-standard N? And in the language Java, it chooses to interpret an enter key or a new line character. We might call it typically new line character. And essentially, it's the act of when you hit your enter key and the cursor moves down. So how could we represent that in the actual language as we read our program? We couldn't hit the enter key because for us, what it does is it moves the cursor down as we type. And so how could we tell the computer, no, I want you to put a literal movement of the cursor into the expression that we're going to print to our console? How do we move the cursor in the console is essentially what's happening, in a way that's maybe not typical. And so that enter key, that enter action, or new line character is with the backslash N. You also might sometimes hear it called carriage return or line feed. Depending on the system you're on, it might use all three notations, and the actual behind the scenes Unicode representation it depends on the system you're on. But for us in Java, we will use backslash N. So let's go ahead and do this. And I'll go ahead and prove it by, let's temporarily print out the symbol, and we'll see what it looks like. So do system.out, println. We'll print out the single letter symbol, and then we'll reassign symbol, and then we'll say it is a single quote backslash N. And again, I mentioned last time that if you put more than one character in single quotes, typically gives you an error. So for example, I put BN, it's a problem. It says, no, you can't put more than one character in single quotes. It does not make sense. It doesn't understand it as a character literal. But here is the kind of one exception to that rule because it understands that this is not two characters but an escaped single character. And so let's go ahead and print it out and let's see what it looks like. So system.out.println, symbol again. And I'm going to print one more thing just outside of it just so we can see the difference. I'm going to put after. And here it is. So let's go ahead and run this and let's see what our output happens to be. So we'll give it a moment and then it'll generate. Okay, and there it is. And so this actually looks like there are more new line characters, more movement to the cursor than we might expect, but we have to pay attention that and not forget that our println, the whole ln stands for new line, and so that means that we are putting more enter keys than we might expect. So here it is. We print the n. And so we said println, so we print the character, and then the ln from the println moves the cursor down, and there we are. And then we store a new line character in symbol. We print the new line character. That immediately puts us in the next line. And then the ln of the print occurs, which puts us on yet another line. And then we print the after new line text, which puts us over here at the end of our line. And then the ln puts a new line. And then the computer finishes up by putting its little green message, build successful. So you can see we can arbitrarily put spaces between lines in our console by adding println symbols directly. And we can use the println command by itself and maybe give it an empty string or things like that. We'll talk about, there's a lot of different ways of kind of moving the cursor down, but one way is to print a single character that's just a \n or escaped n. Right, so that's the first escaped character that we're concerned about. And so there are actually a good number of them. We're only going to look at a few, and really only 3 of them are super important to the AP exam. The concept is kind of important in general. And we may use ones that are not part of the AP exam just because they're helpful. So as an example, let's try something like, I'm going to copy this line to save myself some work in the future. But let's go ahead and say symbol is equal to, and another escape character is T, \T, and \T stands for the tab character. Because again, what does the tab character do on our computer? It moves the cursor over to the right some amount. Typically it's 4 or 8 spaces or 2 spaces. You can, and in some systems you can change that value, and it depends on the editor you're in as well. But the idea is that we can change the tab character. Right? And actually, let's go and put a note up here saying this is the new line character. Right? That's what we're talking about, the enter key. So let's go ahead and print out symbol. And I'm also going to bring up something else that I don't think I've discussed in a previous video. And this is, we're using the println command. This is a print command that puts a new line for us at the end. But if we don't want this extra ln, so if I wanted this to all be shorter, I could have maybe come up with a different way of doing it. And we'll see in a moment that we can. And this is by, instead of saying println, if we just put print, it is also a command. And this command says, print out the content, whatever's inside the parentheses, but don't put an extra new line character at the end. So if we use print, it's either our responsibility to put a new line character ourselves, literally in some fashion, as a character, as a string or something, or to call another println afterwards, or accept that the cursor will stay on the same line where it is. And I'm doing it on purpose here because I want to see the tab and then some words. So I'm going to go ahead and add a note here saying system.out.print prints, okay, without a new line, right? So the idea is that we don't see that extra new line. And because the cursor's on the same line, now I can go ahead and do something like system.out.println, and we'll put after tab, and then there's a new line at the end of this one. So now let's go ahead and run it and see what happens. So last time we got to after new line, and then here we are. The ln of this print brought us to here. And before the green text was there, but now we print out a literal tab character without a new line. So that brings us right here. The print did not shove us down a line because there was no ln. And then the next print prints the words after tab, and then the period, and then an ln from the new line, and then that's how we end up over here. So we can control this pretty effectively by playing around with different characters. And I'll point out, notice the cursor in my output, when I press my right arrow, it jumps from there, because that is one tab. And if I highlight, that is one unit. Again, depending on where you are, what system, what program you're in, sometimes tabs are converted to spaces, sometimes tabs are one chunk like this one, and sometimes they're 4 characters in 4 spaces in width, sometimes they're 8. And so here, if I count it's about the same as 1, 2, 3, 4, 5, 6, 7, 8 characters wide. So notice how that matches up with the tab. That's about 8 characters wide, and that just might be a setting in the console. We could probably play around it if we wanted to. So again, another useful escaped character is the \t. Again, what we're saying is the escaped character says, interpret the thing after me in a non-standard fashion. The standard literal T would be the letter T. And so an escaped T means the tab character. And there are a few other ones. So like \B would be the backspace, and delete I don't believe has one, or if there is, I don't know it. But the idea is that we're not going to cover all of them. There are a variety. There's only 2 other ones that I think are important. Or 3 other ones actually that are important, and 2 of those are on the AP exam. So right now, and I'll go ahead and put, this is a focus of the AP exam, so I'm going to go ahead and put AP exam. All right, so that one, the \n, the tab, they will never test you on. You could use it potentially, but they're not going to show code that has \t. So the next 2 I'll mention exist because of the opposite problem. So the problem of the \n, the \t was that there is no visual representation. There's no symbol representation of these things. If I tried to put, and I didn't do it, but if I tried to do this, symbol equals, and then single quotes and hit enter on my keyboard, that's what happens. And that's not correct. See that there's no symbol for the enter key, so that's why the \n must exist. Likewise, if I did this and I hit the tab key, it doesn't recognize it for whatever reason. And then you'll notice here when I hit tab, I'm hitting tab right now, it only puts 2 spaces worth of characters, not 3. So 1, 2. And so that's why we can't do that, so we need to have the escape characters. The next 2 that we're going to see are not because of that issue, but because we're trying to print out a character that's in the language, in Java. And so the first one I'm talking about is the single quote. If I want to display a literal single quote, right? I want to have a single quote show up after this. The problem is if I try to do this and go between the 2 single quotes of the literal and put a single quote, first of all, NetBeans kind of sees me as autocomplete, tries to push me over, and if I put another one, it puts double. But if I did that, if I was able to write this out manually, it does not work. Because what it sees is, it sees an open quote for a literal character, it sees nothing, and then it says a close quote, so well, you didn't put anything inside of the single quotes. That's one problem. And then you opened up another literal character, and then you never closed it. And so it does not interpret this as, a literal single quote. And so this fails because the language Java must use these single quotes to represent some data in its language. And so we're kind of trapped. And so the solution is to escape the single quote. And there it is, no problems at all. So now we're saying print a literal, or save a literal single quote value. So again, the standard behavior for a single quote is character literal. The alternative is a literal single quote. So it's like the reverse of the other ones. So now if we run it, we can see that we have a single quote printed, and there it is. And then there's a new line from the println, so we end up with on the cursor right here, and then the computer prints out its message. So there it is. And so in a similar fashion, the double quote has the same problem. The double quote we've been using for literal strings, but with that said, in the example of a char variable, it's not a problem. We actually have the option to do either one. And so if I do symbol equals, I can do this, and there's no problem. So I'm going to go ahead and print it. And there it is. But now what we're going to move on to next is going to be strings, and strings are in double quotes. So if I attempt to put the double quote, for example, after tab, and I try to put a double quote here, again, immediately you can tell the editor is stopping me. It thinks I'm trying to close it off. If I put it right here, we're going to see what happens. It puts one there, and then it fails. And if we think about it, it's saying, okay, here's the beginning of a literal string, and then here's the text of the string, and then there's the close. But for me, it wasn't meant to be a close. It was meant to be a literal double quote. And then it fails. It says, this is not a variable. You're using dot incorrectly, and then you opened a string. So there's a bunch of errors here that are not. So it says unclosed string literal, not a statement. It kind of fails all over the place. And so the solution would be to escape the double quote. So in a char type, the double quote does not need to be escaped, unlike the single quote. And similarly, I'll say if I escape the double quote, notice the problem goes away. And if I run this, we can see after double quote tab in our output. So it does kind of conveniently work out for us. I'll make this a little bit bigger. So that's convenient. But then now the same kind of reverse applies, that if I wanted to put a literal single quote, I wouldn't have to escape it in the double quotes because it would recognize it. So they're kind of like partners in reverse of one another. And so we just have to be aware that technically both of them do have escape sequences. And I'll go ahead and put that in a separate thing in a moment. But if I tried to put an escape character on the double quote here in line 71, it wouldn't be a problem. Either way is acceptable. So in a single quote, we can get away with not escaping or escaping the double quote. In double quotes, we can escape the single quote or not escape the single quote. But the idea is that both of these issues arise because of the fact that the characters have meaning in the Java language. And so from this, I wonder if you can guess what other final symbol I'm going to discuss that has the same problem. Right? So I'm going to give you a second to think about it. What if the fear is a character that's being used in the language has a meaning and we can't kind of get away from it? What other character has that problem? Right? That's the question we have to ask. And so unfortunately, since we're not live, I can't get an answer from a student, but we're going to go ahead and say that the other and the final one that's important. Now I'll mention the double quote is important for the AP exam, right? And again, in this situation on line 71, it's not necessary to escape it, but we'll talk more about it. But I'm going to write it down as well. AP as a note. AP exam, right? And so that last character that I've had you think about is the escape character, the backslash. The backslash itself says, interpret the next thing as an alternative. But what happens if the thing that I want is a literal backslash? So let's go ahead and try. If I say symbol equals single quotes and I put a single backslash, it fails. Because it says, well, I'm escaping the single quote. Where's the end of your single character? Where's the second half to this one? It's misrepresenting what's actually going on. So what is the solution? And it may seem silly, but the answer is to escape the escape character. And if we really think about it, it's not unreasonable. We're saying, if the escape character says, interpret the next thing in an alternative fashion, then what we're saying here is, escape the escape character. Meaning, instead of interpreting it the normal way, as the escape character, interpret it as the alternative, a literal backslash. And so now if we print it, we can see that a literal backslash will appear. And so later on, when we get into file systems and paths and printing and reading from data from files, we will use backslashes because Windows often uses backslashes. And so you'll never see a literal backslash that's not doubled up. And this is the reason that backslashes must be escaped. The escape character must be escaped to be used literally. It's very odd, but it is a symptom of defining one language using another language. We're defining a language to write code that does something, but that itself is another language, and we're sacrificing utility in some symbols, and we have to come up with another solution. And the escape character is that solution, as odd as it may seem. So now I'm going to move on to the same thing, and these escape characters are also very important to strings. The same ideas apply, and we'll do that in a moment. I'm going to go ahead and put my final note here for the AP exam. And so those three escape characters that we care about for the AP exam are the \n, the new line character, the \, double quote for double quotes literally, and the \/ or the escape character literally. And the \, single quote is important, but the exam does not focus on chars at all, so that's why the single quote is less important to them. But we should know it because we might use characters, data types a lot. So let's make some string variables, and we'll talk about string literals. We've been using them kind of instinctually. I've kind of, from the first day we did Hello World, we've been using double quoted things in our prints, and those are literal strings. So let's be a little more formal about it. So let's call it something like student name, and let's declare it as a variable, and let's go ahead and assign it a value. So here we go. We're going to go ahead and say student name is equal to Jimbo. And there it is in double quotes. I had to literally double quote it. And if I tried to put single quotes, it would fail because it would not be a single character. Strings are sets of 0 or more characters. And I say 0 or more on purpose because I'm going to show you next that it is possible, as strange as it might seem, to have a string with no characters in it. And we'll see in the future that there actually is a pretty solid purpose to that, and it is helpful in a lot of situations, as odd as it might seem initially. And so if I go ahead and print out not symbol, but student name, and I run this, we should see Jimbo printed out. And just to be clear in the reminder is that capital letters and lowercase letters are distinct. So capital Jimbo with lowercase Jimbo are not the same string. They have different values, potentially. And now let's go ahead and do something. I'll make another string, and I'm going to call it empty. And I'm going to say empty is equal to double quotes. And that is an empty string. That is the common terminology. So I'm going to go ahead and write a note here saying strings that contain no characters are often called empty strings. Right? And that's just like kind of a name for it. The idea is that it has no content. And again, that is distinct from this. That is not an empty string. That is a string with one character, a literal space. And those are different. And so when it comes to handwritten code, what will happen is if I'm reading your handwritten code, I'll do the same thing the AP graders do, and they do their best to give the benefit of the doubt to the student. So if you are someone that your handwriting is a little sloppy and you sometimes put more space than you might think, and you might be worried, oh no, they're going to see it as a space and not an empty string, it's not a problem. They'll assume for the situation, the context, that, oh, this requires an empty string, they must have meant empty string. They try to do their best to give you the benefit of the doubt. And as long as it's not blatant or brazenly super spaced out, they won't do that. And that's the only way they'll really get picky, is if you try to make it so spaced out that they think, oh, he must have really meant, or she must have really meant a space. But there is an empty string, and empty strings are allowed. Now, if we print an empty string, do we see anything? And so I have a new line character, don't forget, on the println, so let's run it. Oh, I'm sorry, I'm supposed to print empty, not Jimbo. So let's print out empty. And there it is. So what actually happens? So we printed our literal backslash, and then the ln brought us over here. We printed with println the student name, which brought us here, and then the ln brought us here. And then we printed the empty string, which has nothing, which immediately puts an ln and next to it. So an empty string shows nothing. It takes no space. So the only thing that's on this line is a new line character, and that's because of the ln, not because of the empty. And so the empty string, when you print it, has no visible representation. It is printable. It is a valid string, but it is not meaningful beyond that until later on. In terms of printing, it has no real meaning. So I believe we're going to stop here for this video as we finished up our literal types. And I'll point out, I didn't say it, but I'm going to say it one more time here. The categories of things that we did: ints, doubles, booleans, char. Those are all primitive data types. We discussed primitive data types before. They can easily fit in single positions in RAM. Strings are not primitive. And I'm going to write it out as a note one more time. I know I put them in the same file here, mainly because strings are so important. We use them all the time that we have to be comfortable with them pretty quickly. But they are not primitive data types. And we'll see that one of the reasons, is they have extra functionality, a lot of it, that we can use to our advantage. We haven't done it yet, but we will shortly be able to do all kinds of things with strings that you can't do with primitive values. And the technical reason is more about the memory usage and how there's more content. And just some hints that give it away: the type is not lowercase. The editor does not color it in a different in that orange fashion, so it's not a primitive type. So I'm just going to go ahead and put that note real quick. So I'll stop our video here, and we will continue in the next video with a new and interesting step forward, which is the arithmetic that we can do in Java, which is very similar to the math that we do in our everyday lives. I'll see you in the next video.